Hello guys, welcome once more to class online. My name is Dami, and as we know, this edition of Jamb Physics 2012, we've gotten to question number 41 to number 45, and we shall be explaining these questions in a way that you will be able to understand so much in it. You have many questions that you have not understood about magnetism. They will be well explained in this video, and by the end of this video, you will have a perfect understanding of how to tackle questions or calculations in magnetism. Now let's get to the video. Don't forget that if you learn something from this video and you want to get more content from us that will help you understand much in physics, we have a load of content to share with you that will explain so much to you in physics. Now just click on like button and we'll get to reach you with more content that will explain so much to you in physics. Number 41 says a particle carrying a charge of 1.0 times 10 to the power -8 coulomb enters a magnetic field at 3.0 times 10 to the power 2 meter per second at right angle to the field. If the force on this particle is 1.8 times 10 to the power -8 Newton, what is the magnitude of the field? Now, whenever you have a question like this is a magnetism question. Now, there's one major formula in magnetism that you need to know, and that formula can undo most of the problem you have in magnetism. Notice that you were given charge 1.0 times 10 to the power -8 coulomb, that's charge. Then you were given speed v 3 times 10 to the power 2 meter per second, and you were given a particle and you were given that force. It has a force of 1.8 times 10 to the power -8 Newton. That means that the formula to use for this question is just the magnetism formula, and that is this: F equals QVB, where F is the magnetic force, and in the question it was 1.8 times 10 to the power -8 Newton. Then the Q is the charge, and that's 1 times 10 to the power -8 coulomb. Then the V is the velocity, that's the speed, that's 3 times 10 to the power 2 meter per second. And you were told to find the magnetic field, and that is B. And you know, of course, B is measured in Tesla, so the magnetic field is my B. That is the magnetic field flux. And then we just find the B. So how do you find the B from this formula? That's F equals QVB, right? So remove the B, make B the what? The subject. That's solve for B. So QV will move from here under F, and that will become B, or magnetic field, equals F over QV, right? Now what's the F? The force, 1.8 times 10 to the power -8 over Q. What's the Q? 1 times 10 to the power -8 times V, 3 times 10 to the power 2. So if I'm solving this further, I'll just number to number. I've told you that don't multiply 10 with the number. Separate the 10 to one side, then the number to one side. That will become 1.8 divided by 1 times 3 is 3. That's 1.8 divided by 3. Then all the 10s. 10 raised to the power -8. The 10 raised to the power -8 below will go up. It will become plus. And that will become 10 raised to the power -8 on top. Then the 1 below will now become plus 8. Then the 2 below will go up and become -2. And that's it. So whenever things below powers below are going up, they will change sign. Okay, so that will become, that's what I have here. So 10 to the power -8 and 10 to the power 8 will become 1. That's it. They will cancel each they will cancel out. Remaining 10 to the power -2, and that's it. So we have 1.8 divided by 3, that's 0.6, times 10 to the power -2 as the final answer. So that will become, if you put it in standard form, it will become, that means you will move the point from here to the front of the 6. That will become 6 times 10 to the power -3 Tesla. And that is the answer for the magnetic field. Don't forget that everything came from the magnetic formula, force equals QVB. Okay, that is the ultimate formula for any question on magnetic field. And that is the way to answer this question. So our answer is 6 times 10 to the power -3 Tesla. And that is option C. Number 42 says, which of the following is the correct shape of the graph of capacitive reactance, that's XC, versus frequency for a pure capacitor in an AC circuit? Now, this question cannot be fully demonstrated in this video, but we'll just give the answer to that question and we'll move on. But in a later video, we will want to break down AC circuit because there is so much explanation that can only be explained on the topic and not on the past question. So you might want to check out your textbook for this aspect in the AC circuit, because AC circuit is a broad topic on its own in physics. And so the graph of relationship between frequency and the AC circuit is this graph, and it is as shown by the formula. You know, the capacitive reactance is 1 over 2 pi fc, where my f is my frequency and the c is my capacitance. Okay, so that it is inverse. So it is an inverse relationship. That means that the slope of the graph will be from the left hand side to the right hand side, and it is slope from up to down. That means it will slope this way, and that's what you have there. It is slope this way, but it will tilt a little in, and that shows that it is not directly proportional. They are actually inversely proportional to each other, and therefore the answer will now be option D. It is an inverse relationship. You can see that from the formula, that this is inversely proportional to frequency. That means capacitive reactance is inversely proportional to frequency, and it was shown by the graph this way, and that is the answer for number 42. Number 42 says the current output from form of an AC source is given as I equals 10 sine WT. The DC equivalent of the current is what? Now that is not supposed to be, this is a mistake. It's supposed to be I. That's current, not 1. Okay, so the correct expression is I equals 10 sine WT. So we are finding the DC equivalent, right? Now don't forget that in the AC topic, when we're taught AC circuits, we're taught that V RMS equals V peak over root 2. Okay, and where the V RMS represents the voltage of the DC, not even DP. I was putting DP here. It's not DP. It's DC. So that's the current. The voltage of the RMS is the voltage of the direct current, while the voltage at peak is the voltage of the alternating current. So it should be DC and AC, not DP and AP. This is for direct current, and this is for alternating current. Then over root 2. That's, I have my current now, direct and alternating. So I'll plug in the value for the alternating current on the alternating current section here, and that will give me 10 over root 2, because this 10 is an alternating current, right? So put it on the position for the V, for the peak voltage, and that will give me 10 over root 2, and that will become, so the direct current is going to become 10 over root 2, and that will give me 7.07 ampere. Don't forget that voltage at RMS is equal to the peak voltage divided by root 2. That is very, very important. Okay, that, and then you might be saying, what's the meaning of RMS? It is root mean square. That is root mean square voltage, and that is the answer for finding the direct current, the current of the direct current, and that is the answer for that section. So the DC equivalent of the current is going to become 7.07 ampere, and that is the answer, approximately 7.1 ampere. That is the answer for that. Then number 44 says a conductor of length 1 meter moves with a velocity of 50 meters per second at an angle of 30 degrees to the direction of uniform magnetic field of flux density 1.5 WBM per meter square. What is the EMF induced in the conductor? Now, this is also a magnetism question, right? But previously, I worked on a magnetism question that does not have to do with density. Now, when you see density in magnetism and you are seeing an angle in that question, you need to use a formula that is slightly similar to the previous one, but with a little alteration. And this is the formula: E equals BIV. Of course, the first one has B and also have V, so it will become E equals BIV sin theta. This is a modification of the previous formula. It is now going to become EMF. E is EMF, and the EMF is what we are looking for. Then the B is the magnetic flux. It is 1.5 BWM per meter. That's per meter square. Then the I, that's the current. Not I, please. It's length. It should be E equals BLV sin theta, where my E is my EMF, which we are looking for. My B is the magnetic flux, which is 1.5. Then my L, not I, but L, length is 1 meter. The V is the velocity, which is 50 meters per second, and the theta is the angle, which is 30 degrees. So now plug in all the parameters into the formula. That will give me E equals 1.5, okay, times my length is 1 meter, then my voltage, the V, is 50. The not voltage, velocity is 50, and then the sine of the angle is 30 degrees, and that's 30. So I will multiply it now. 1.5 times 50 will give me 75 sine 30. Sine 30 is 0.5. 75 times 0.5 is 37.5 volts, and that is the answer. Most importantly, it's not the answer. Most importantly is the way it is worked. And so is the formula by which you derive the answer. Take note, if they ever mention magnetic flux with an angle, this is the formula to use to find the EMF. Okay, but if it is just magnetism, then you can use the previous formula that we discussed previously, and that is the answer. The answer is 37.5 volts, and that makes option A the correct answer to that question, right? Now let's check out number 45, the last one for this video. The process of detecting a pin mistakenly swallowed by a child is X-ray what? Now, if you have a baby at home and the baby swallowed a pin, how can you detect the pin position in the stomach of the baby? How can you find the pin? Of course, if you are going to remove the pin, you have to first of all find it, because if doctors are going to operate on that child, they will need to open the stomach, and they can't just open anywhere. They have to open right where the pin is staying in the stomach. So they can't just open the stomach and start looking around for the pin. That's not how they operate. So they have to open the part of the stomach where the pin is located. And before they can do that, they have to perform an X-ray of where, to know where the pin is located. So what's that called? X-ray what? Is it X-ray diagnosis, or X-ray therapy, or X-ray crystallography, or X-ray mammography? Now, let's take a look at all these terminology. They are all medical terms. So, first of all, we have X-ray mammography. It's an X-ray picture of the breast. Now, doctors use a mammography to look for early signs of breast cancer. Mammography is limited to the breast to detect breast cancer, and this is not a breast cancer question. So, A is wrong. Mammography is wrong. Then X-ray, diagnostic X-ray or radiography is a special method of taking pictures of areas inside the body. A machine focuses a small amount of radiation on the area of the body to be examined. Now, this is a picture of an area, of a section of the body. That's to look at the area in that body. And that, I believe, is the answer, because if the child swallowed the pin, then you need to X-ray the layers of the stomach and look for which area has the pin, and you can only do that under diagnosis. So it is diagnostic X-ray, and that is the answer, or it's also called radiography. Now let's check out the others. We have X-ray crystallography. Even from the word crystallography, you will know that it has to do with crystals. Okay, it's a tool used to determine the atomic and molecular structure of a crystal. This is limited to crystal. Now, this question is not a crystal question, so this is off. Then radiotherapy, radiation therapy, or radiotherapy is the use of various forms of radiation to safely and effectively treat cancer. Therapy is treatment to cancer, and this one is not correct. It's not treating any disease. We are only looking for a pin inside the stomach of a careless baby, and that is only possible with diagnostic X-ray. So the answer to that question is diagnostic X-ray. It is X-ray diagnosis. Now, if you look in your past question, I've checked through some past questions. I saw that they were going for crystallography X-ray, and however, that is very wrong. So always watch out for some past question might pick the wrong answer. So that you will not fall for that. So cross-check some of those answers. Some of those answers are they are super wrong, and that is just it. So the answer is X-ray diagnosis, and that is the answer for number 45. That brings us to the end of this section. Don't forget that if you learn something from this series and you want to get more content from us, click on the like button. We have a lot of content to share with you that will better help you understand physics. Until we see you again, guys, take care of yourself and bye for now.